Hello, everybody. Can you hear me and see me all right?
I'm good.
Excellent. Very good. And can you see my screen?
It's currently black for me, but I did get a presentation.
Okay, let's see. Do you see something that looks like a Sublime window now?
No, not yet.
All right.
I can try.
I'll share from my desktop. Okay, how about now?
Okay, that's better.
Excellent. And for other folks, do you see the screen all right?
Yes, I can see it.
Okay, I'm getting some Blue Jeans chat. Yes. Okay. Excellent. Very good. So welcome to the delayed by 1 day presentation of DataFu and how we can use it to do some interesting stuff. I'm going to try to cover some of the things that I think are going to be most interesting and most useful to the sort of the kind of work that I expect that the different teams are doing. And then I'll be able to answer any questions for those that have already had sort of experience with DataFu and have found it working or not, if that is the case. All right, so now, and I'm going to give folks a few more minutes to sign on. Like we have 1, 2, 3, 4, 5 participants right now, and there were a few more folks that replied to the calendar. So I'm gonna, give like till 7:10 before we get going. Yeah. All right. And I'm gonna turn off all annoying alarms so that this presentation doesn't get too disruptive. And if you have questions or you want to interrupt me, please go ahead and do so either via chat or just unmute and go for it. And just sort of a quick survey, how many folks have already realized that they need to get some statistics other than what's built into Pig, or that are actually tried out some of the Pig statistics stuff and were left with questions?
Definitely our team.
Yep. Anybody on chat? Looks like no. And I know that Natalie's team was looking to see this presentation. I don't know if anybody's from that team is on yet. I'm going to hang out a few more minutes waiting for that. All of the stuff that I will be right? All of the stuff that I will be going through, sort of the scripts that I'll be showing and sharing and trying out, are already available in a Google Doc under the, that's shared with everybody. Google Doc is called DataFu, and it's in the shared docs folder underneath the EGC folder on the Google Drive that we're all sharing. All right. So just to start, Apache DataFu is a library that started out at LinkedIn to help us do some of the sort of trickier manipulations on HDFS using pig that wasn't sort of simple and straightforward to do with just pig by itself. And it's a library of UDFs that we here have open sourced for a while, and right now it's an Apache incubator project. So it's sort of like becoming mature open source. The datafu.incubator.apache.org is a great site to get started with, to get some more details, get more nitty-gritty into the actual implementation if you are so inclined, and just a good reference for the future. And also, if you want to become a contributor, and this would be the source to go to. Okay. So with that, let's get started. A few items to take care of. DataFu is available right now on Bridge. The version of DataFu that's available on Bridge is not sort of the latest and the greatest. And because of that, if you want to try some of these out right now, you will need to do some extra work. Specifically, you will need to download the DataFu library from a distribution. The link is included in the document. Then you'll need to SCP that library into your home directory on the gateway machine using WinSCP, or if you have some other tool set up, you can use that as well. And we will go ahead and try to get the latest version of DataFu up there soon, so you don't have to do this first setup. But if you really can't wait and you're interested in getting this done now, just follow the instructions here at the top. Once you've got that all set up and ready on Gateway, I'll show you that I have done that work. And let me share my terminal. I have done that work, and if I list my home directory and gateway, besides all the error logs that you see here, you also see the DataFu library jar in the root of my home directory. And when I start pig, the very first thing I want to do is actually register that jar with my pig job to make sure that all those functions that are included in that library are now available for my pig script to use. So we'll just go ahead and do that, and this is it, just a simple one line. It registers it, and we're good to go now. Now, the data set we're going to work with is going to be endorsements. I picked it because it's sort of like a relatively large and interesting data set. I imagine some of the teams might find it useful also to use this data set for their projects. So we'll go ahead and load that in. Now, if you've actually attempted to use the endorsement data sets, you will very quickly realize that it's a very large one. And if you try to read the entire data set and sort of do any kind of analysis on it, it's going to be a time-consuming process that's going to require lots of cycles on the Hadoop cluster to get a result out. So the very first thing that I am going to sort of introduce here are some of the sampling capabilities that are built into DataFu. Now, there is a built-in sample function or sample sort of capability within Pig. So you can simply just say, sample and is equal to, sample endorsements. And then enter a percentage, and Pig will sort of do its best to read your data in and sample it and allow you to just select a portion of it. The implementations available within DataFu give you a little bit more flexibility, and we'll sort of take a look at some of that right now. So the very basic one is this sort of simple random sample, which is similar to what Pig does, but has some nice nice properties, and it can sort of get you close to getting you the size of the sample that you've asked for. So for example, we'll go through this definition in parts. So the first step here is to define a UDF, and that is the declaration that you make to Pig that I am going to create a function called SRS, and this function is actually going to be this UDF, which is simple random sample, and as input to the UDF definition, we're going to provide the size of the sample we want. So the range here is from 0 to 1, where 0 is no data, 1 is all the data, and the way I have it set up, this is going to pull just 1% of the data, right? Was there a question? Nope, I guess it's just the door opening and closing. Moving on then. So even with this sample here, it might not be enough. So I looked at this earlier. The total size of endorsements records that we have now in the data set is close to 8 billion records, or 7 billion plus records. And even a 1% sample of that is close to 80 million, right? So it's still a relatively large data set, certainly way smaller than the original data set, but still much too big to kind of work with. And DataFu has capability that the Pig sampling doesn't. It has a capability to let you specify the size of the sample you want. So say you want to work with only 1 million records, or 10 million, 100,000, whatever it is, right? So for that, there's another set of UDFs that allow you to expose this functionality using DataFu. And we'll take a look at these next. So they come as a pair of UDFs, and they sort of collaborate together to give you the precise sample. Let me switch back to terminal and sort of show you what that looks like. So here are the two UDFs. One is called simple sample with replacement vote, and the other one is called simple sample with replacement elect. You apply the vote sample first, and that sort of gives you makes a decision on the record whether it will be included or not. And then later on, you use the replacement elect to actually select just the records that were included in the data set. So you combine these, and they work together as a tandem to give you a more precise definition. And what you need to specify to it is the size that you want, which I am specifying right here. That's 1 million records. And then you want to specify to it the size of the data from which you're selecting, right? So I've already downsampled to 80 million records. So that's how I know that the endorsement sample size here is 80 million records. I actually ran a Hadoop job and I saw, how many records this had, and that's why I can input it here. And you have to specify these inputs, as well as you have to select a value that you want to sample now, or a value that you want to keep around in this sample. So here I'm selecting the endorsements ID because what I want to do is I'm going to generate just the sample set of IDs, and then I will use the IDs that are generated to actually downsample from the raw data and select just the endorsements that I'm looking for. So if you look at the description of what the endorsement candidates has now, which is this sort of applying the first UDF, endorsements candidates, you'll see there are sort of some auto-generated fields that look kind of strange. So the position and score are the sort of things that are produced internally by the UDF, and then the candidate field is the actual field that we've asked it to sample, or we've asked it to keep around for the terms of the sample. So then the next step, which is to actually select the actual sample of the correct size, you need to then execute another statement. And here what we're doing is we are grouping all of the endorsement candidates by position, which is this field that was created by the other UDF. And then from there, we are using the elect UDF to select the data that we're looking for to help it. So this is going to provide us the sample. Now, one thing to note here is this parallel setting here. So what this will do is it helps you control how many resources you use to execute this group by statement. So it basically controls the number of reducers that are used to execute the group by, and the number of reducers controls how many data sets are output. And you can basically increasing this number will, to some extent, make your jobs go faster if you're working with a big data set. So in the end, what this will do is actually, and I'll describe, is actually select sort of close to 1 million, and does a pretty good job of endorsement IDs, right? So now that I've captured the sample of these endorsement IDs, I would then need to go ahead and actually join it with the endorsements data set to make sure that I get sort of the full record. I played around with using this function and using this setup to try to get the record just as part of the bag, and I wasn't able to figure out how to get that done so that we wouldn't have to do the second join. It's a takeaway on my part to figure out how to get that done. So, basically what I would do then is join this against endorsements, and now I would have a complete data set. So all the endorsements, the join would actually select only the ones that match the sampled IDs. So now my small endorsement sample is going to be 1,000,000 endorsements, a much more reasonable data set for me to work with and kind of do some experiments on and work in the in the terminal rather than needing to go ahead and kind of kick off a script and wait a couple of hours before it comes back. So one thing I wanted to show here, and this is a known issue in Avro. So if I with using Avro storage, so if I describe this data set here, what you'll note is that the fields in this data set all have this sort of two colons back to back, and it's a way that Pig disambiguates. It's like a prefix, like a namespace almost in this data set. And after you do a join, you'll see that this namespace appears for the two different data sets you've combined, right? So here I'm combining endorsements, so I'm seeing the endorsements prefix for some of the records, and I'm combining with this endorsements 1,000,000, and you see that prefix there. And the reason that these two are set up is so that there is no name collision on the actual fields, right? For the most part, this is not something that might become a problem. With the one exception of if you now want to go ahead and store this data set using Li Avro storage, you will get an exception. So that's worth kind of demonstrating. Into using Li Avro storage, right? And you get this weird error, which actually doesn't point you to any clues to what's going on, right? It says info, Pig using script, error, unable to store alias small endorsement sample. And if you actually go ahead and inspect this log here, you won't necessarily get the clues that you need to know how to repair this problem. But I'm going to sort of give you the shortcut. The way you want to handle this is by projecting all the fields out again and aliasing them to their field name without the prefix. So as an example, I'll show you how I would do that for the small data set. So I go ahead here and just project all the fields, removing the prefix from the name. And now if I run that same function now, it's going to run just fine. It's not going to have a problem. Okay. So let me pause for a second because I feel like I'm talking to the camera and not actually people. Does anybody have questions so far? Can folks hear me and see the presentation all right?
Yeah, I've been following. I'm good.
Excellent.
I'm good. I'm good too. Everything is clear.
Okay, makes sense. Thank you. Great. So I'll move on. So one thing to note is that endorsements, can be joined to members, right? And you might want to your work might include actually figuring out, for a particular company, do people get endorsed more for a particular skill, for example, right? So you'd like to be able to join these two you like to be able to join these two record sets and sample them and downsample them together, let's say, right? And the way you do that with, if you just using the pig sample application, is you would, sample one data set, and then you would join with the other data set, and then you would sort of store that, right? And the nice thing that DataFu offers is a way to have key-based sampling. So you can take advantage of the fact that there is a key in the endorsements data set that refers to a key in the profile data set, and you can sample both data sets and make sure that the keys that are preserved in one are also preserved in the other. And you don't have to do the join. You can just do this sort of sampling, and then you know that your data doesn't have like missing gaps, right? And that you're not missing out any folks that like are in one sample but not in the other. So I'll show that that other sampling method, right? So it's just called sample by key. It also takes be clear here. It also takes as an input the percent of the data set that you'd like to sample. And once again, it goes ahead and it's specified as range between 0 and 1. And here I'm specifying 1%, right? And the way you'd use it with the two data sets is in a filter. So you would go ahead and filter the endorsements by this sample by key, and you would pass in the key that you would use regularly to join to the identity data set. And then you would, of course, need to load the identity data set. And apply the same filter to it, taking care to use the same field, right? So the ID field in the profiles is something that maps to the recipient ID in the endorsement data set. So then, if you were so inclined, you could then sort of group all of the endorsement by the recipient ID, and then join that to the profile data to kind of have this bag of endorsements attached to each profile, right? That might be a nice setup for you to do further analysis later on. So let me just describe the profile with endorsements here, just so we see what's going on. And then we'll move on to our next set of functions. So this goes ahead and adds the endorsements right here to the actual profile data. So now it's kind of like, this makes it look a little bit like what you would see on the profile page, where you see the members' endorsements alongside the rest of their data. Okay. There is one more sampling technology that's available, and it's weighted random samples. And I couldn't really come up with a good example to demonstrate it. But the documentation is available on the, let me show you. Documentation is available on the DataFu site, and you can see if there's something in this sample method that applies to you. All right. Great. So now I'm going to move on to the other aspect of DataFu that I think might be useful to folks, and sort of one of its strengths are some of the sort of stats functions that you all might need when you're examining this data that are not sort of available out of the box in Pig, and as well as I will introduce some of the basic stats stuff that is available in Pig out of the box. So I went ahead and did something here and pre-baked a little sample of endorsements, and we can kind of use that data set to demonstrate the rest of the library here, or the rest of the library that I'm going to cover today. Okay. So I'm just loading something from my own private stash of data, and this is a small endorsement sample of about 1 million records that I was able to generate using the sampling function UDFs that are available in DataFu. So it works. I guess is the primary takeaway there. So one thing to note about the UDFs that are available in DataFu for calculating statistics is that they generally work on grouped items, right? So you want to count something, then group it by what the label of the field that you're interested in, and then once you've done that, then you want to go ahead and apply some of these stats UDFs to the counts. So I'm going to do something similar with the endorsement data sample that we have, right? So the first thing I'm going to do is just group the endorsements by endorsed item, and the endorsed item are the sort of labels that you see on endorsements on people's profile. So like Java or Pig or DataFu, right? That would be endorsement item. That would be what you'd see there. Then once I've grouped them, what I'm going to do is just going to generate a count. And so what this does here is now I have for each endorsed item, I'm going to get the count of how many of these endorsements were issued, right? And then one more thing that I'm going to do is then I'm going to sort of, now that I have, for each item I have a count, what I'm going to do is I'm going to group all this data together. So now that I'll be able to, figure out if any of this data is interesting. If there are some, if there's different breakdowns, I'll look at this data and see if any of this is interesting for me to investigate further. Okay. That's interesting. So I'll describe item groups so we see what we're talking about. So this is now a group. The first value here is all basically everything is kind of brought together into one data set, and then the endorsed item counts itself has like an item and then the actual count, right? So there are 3 statistics functions that are available in DataFu that are going to be useful, that might be useful to you. So there is quantiles. So you can see by sort of quantiles or percentiles how many, in this example, for example, we'll see at the 50th percentile, what is the count of endorsement? No, what is the count of a particular item that's been an endorsement item? How many times has that one been issued, right? So if you look at it at the 50th percentile, you know that up to 50% of all endorsement items have been at this count or below, meaning they've been given out, the endorsements have been given out this many times or less, right? And same thing for 90th, 95th, and 99th. And at 100 percentile, you see like it's basically equivalent to max, right? That's what 100% would be. And once again, these are expressed in percentages. So this is 25th percentile, 50th percentile, 90th percentile, 95th, and 99th. Okay. The other one is median, right? This also might be interesting to see, if we go ahead and line up all of the endorsements by the number of times that they have been issued, which one of them, what's the median value for that data set? And then one that I've already been asked about is variance. So there's a var function that lets you calculate variance in a data set. Right? So those are the three statistics functions that are in DataFu, and they're complements to things that are available in Pig, right? So there's a max function that's available in Pig, and there's an average function that's available in Pig. And just to sort of kind of elaborate a little more on developing these. So, a variance function would require you to store sort of quite a bit of data in memory to actually calculate variance. And the Pig UDF that's implemented underneath the covers here actually is able to sort of combine the data as it's being calculated. So it doesn't need to keep all the data in memory, for example. So that's one advantage of using an existing library or writing a UDF in Java versus Python, is that you have these interfaces that let you define a more rich interaction for UDF that helps you offset some of the needs of keeping everything in memory, for example. All right, so let's see what we can do with these functions. So I'm going to gather some stats on our endorsed items and see what those look like. And I'm just going to sort of demonstrate all the stuff that's DataFu offers or that's built into Pig. So we have the median, var, average, the quantiles, and the max, right? We're going to go ahead and do that. And actually, I'm going to going ahead and dump these. So this is because we've grouped all. So this is everything is going to basically it's going to be one row that's going to analyze and output all this data. And I want to show you what this data looks like when you dump it out, and also demonstrate that with a small enough data set. And here is like 1 million endorsements, still non-trivial, but smaller than the entire endorsement data sets. You can actually expect these statistics, these calculations to return in a reasonable time, right? Well, you don't need to kick this job off today and then come back in the morning after a good night's sleep to reinterpret the data. On a small enough data set, you can do it kind of in real time, or near real time, right? You can have a real working session. So you see this is progressing quite quickly. And so while this is wrapping up, any questions about what I've introduced so far? All right, sounds like everything is going okay. Great. So this actually turns into a couple of jobs, but they're all relatively small jobs that are turned around quickly. Yeah, this one already started out at 75% complete. So in a moment, we'll see the data, and I want to take a look at it and sort of explain how these outputs map to each other. All right, so here we go. So here's the actual data set right here, right? So we had, you recall, median, var, average, then the quantiles, and then the max, right? So median being 1 basically tells us that there's a whole bunch of functions of endorsements that are just like, given out once, right? And so there's a whole bunch of unique endorsements. So that's sort of an interesting thing to consider if you're doing this work. Then the variance is really kind of, a huge number, bigger than max. That doesn't necessarily make sense to me, but it is what it is. Average is, on average, an item is given out 9 times, like a particular endorsement is given out 9 times. And then we'll see that the max is sort of relatively big, right? So the maximum number of times a particular endorsement was given out is, 17,000. And then here, if you look at 25% endorsements, they've been given out only once. 50 percentiles, and so once again, once, right, agrees with our median number to some extent. Then at 75% of the items have been given out no more than 2 times, and then, 90th percentile. And then at the 95th percentile is 7 times, and then by the time we get to 99th percentile, 133 times, right? So there's these like very few endorsements or very few endorsement items that are given out a ton of times, right? And then there's a long tail of just like endorsements that are just given out once, right? Some endorsement that just not very popular, and that might be part of that, just like how people give out endorsements. You want to endorse people for skills that are well known or something. And then on the other hand, it might be how LinkedIn tells people to endorse others. It might be that we only highlight fields that are that we consider to be important. Like maybe it's some kind of a rich get richer situation. Not sure, but it's certainly interesting data. And then I wonder what that one is that's been given out 16,000 times. So that's that. So any questions on what these how these functions work and what kind of data they give you? All right, let me check. I'm just going to check the chat to make sure I'm not missing anything on chat. Nope, doesn't look like it. All right, great. So I wanted to do another thing, and I just wanted to show how we can use quantiles in a different way, and also how to kind of demonstrate how to maybe count things that don't seem to be easy to count, or how to shape the data a little bit to make it easier to count things. So one of the let me just describe. Just need to rename it. There we go. Let me load my small endorsements data set again. Kind of useful to have a data set that's relatively small and easy to load. You can exit the shell whenever you want to. So let me describe. So small endorsement cell, it's basically the endorsement data set. So you see it has this recipient's ID. and then it has this recipient type, endorsement type, endorsement item. It's a data piece where we looked about endorsement ID, and then there's this other interesting field which is status, and it's a long, right? So kind of interesting what that is. So I went ahead and I looked it up, and it's actually a field that has it's an enumeration of 5 values, which maps to sort of like meaningful fields, right? So I thought that would be interesting to know is, of all of these endorsements, if I'm a recipient, how many of the endorsements that I received are in each one of these particular states or has this particular status, right? To do that, I need to kind of mess with this data a little bit to make it easy for me to count these values by the status. So it's kind of sort of extracting some more information from this one field. And the way that I do it is sort of like this. So for every recipient, I'm going to get the recipient ID just to have a distinguishing key between all of them. It's not necessary, but it's useful. Then I am going to take a look at the status value, and I'm going to decide, okay, this is 0. I am going to give a value of 1 to the unknown field. If it's 1, then I'm going to give a value of accepted to the unknown to the field. If its status is 2, then it's rejected. If status is 3, then it's hidden. And if status is 4, then it's pending. So what this will do is just is going to take all these endorsements rows and going to take that one status field and turn it into a tuple of 5 values, right? So for any particular row, only one of them is going to be set to a 1, and all the other ones are going to be 0, right? But what this lets me do is now group by recipient ID and then count the values in each one of these columns. So I'm going to go ahead and group this data by recipient ID, right? So let me describe. So you see that now I have here, the key is going to be recipient ID, then I have recipients, and that is a recipient ID, and then unknown, which is an int, accepted, which is an int, rejected, hidden, pending, that's an int, right? So now that I have my data in this setup, what I can do now is count these up, and I can, or I can sum them up. I can understand how, for a particular recipient, how many of the endorsements are in unknown, how many are accepted, how many are rejected, hidden, pending state. So now I'm actually go ahead and going to do that counting. Okay. Just a second. Seem to have lost my count window. There we go. I have not stopped sharing content. Share screen. Sorry, it's just technical difficulties. Okay, great. Now we're back on. Let me share my Sublime text window. So this is going to be the function we're going to use to go ahead and sum it up. So one thing to note here is I'm using sum instead of count, right? So I don't, count will always give me, a 1, no matter what the value of the field is. Sum will actually do a mathematical operation on sum values up, right? So if I can get this thing not confused. Apparently not. Let me log back into terminal real quickly. trying to find my. Here we go. Here's the window I was looking for. Okay, here we go. So I will go ahead and collect just these sums, right? So I'll just describe. Not recipients. I want to describe recipient count. There we go. I'll describe recipient count. So now this is just telling me how many unknown, accepted, rejected, hidden, and pending. Just the 5 counts. And then I'll go ahead and gather some statistics over this data. So now I have this data available, the counts. So here I'm going to use a bit of a shortcut, and I can actually group in the statement, right? Since I don't really want to hold on to the grouped results of all the recipient counts, I can just sort of group them in line in the for each statement, and then generate my quantiles based on these counts, right? With arguments null. Oh, yep. I restart my session, so I need to redefine quantile again. Here we go. Okay. So I'm going to redefine them. All right. And now to dump them. So once again, this is a relatively small data set because it's only 1 million records. It's actually less than 1 million records once I've grouped by recipient ID, because some recipients receive more than one endorsement, right? And we're just going to go ahead and group all these together and sort of count them up and see what the quantiles look like. So while this data is running, does anybody have any questions about the material that we've covered so far?
Real quick, for that last command, can you go over again in that for each, when we do that group, is it, so it's grouping by recipient ID when we say group all? Or what's it, how is that working?
Sure, okay. So, sure. So when you go ahead and you can group by anything here, right? You can use like a regular group. You can group by recipient ID, or you can group by something else. When you say group by all, that's almost, think of it like as if you added a field to your data set. In that field, you put a value of 0 or 1 or some just random number, but every record got assigned that same value. And then you group by that field, right? So what this actually does is bring all of your records into one bucket.
Oh, okay, okay.
Yep. But you don't have to do that. Like, you could use any other field here, and then this group statement will group things by that field. The matter of inlining it into the for each statement or pulling it out separately is whether you want to do some other things to it later, right? Whether you want to hold on to that relation or to that, yeah.
Okay, okay. Thanks.
No problem. So we come back and let me show you the screen. Just keep forgetting to share the terminal. So you see here the data is not so interesting. So there are no pending. Then for accepted, for recipients is between 1, and most recipients have 2 endorsements in this particular sample. And then some recipient, most recipients at most ever reject a single or have a 1 pending endorsement, right? So this is not as interesting as a result. But I wanted just to show that you can reuse the quantile UDF many times, right? You don't have to decide quantiles for one field that you're trying to gather information about, and then do another query for another. You can just run them all at the same time. Okay, so that concludes all the prepared material I had for today's presentation. And we have a few minutes if you have questions. Does anybody have questions? Okay, great. Thank you for joining today. I do hope that this enables you to do some work on the data that you weren't able to do before this presentation. And as always, you can email us questions about this library or using any other UDF or even building one. And I think the best documentation for this is going to be the DataFu website that I shared in the doc that's in Google Docs.
Thank you.
Sure.
Thank you very much.
Excellent. All right.
Thanks a lot.
Absolutely. Have a great evening, everybody, or afternoon, I guess, if you're on the West Coast. And we'll see you all in the next office hours.
Okay.
Bye.
See ya. Bye.
Okay, see you guys.